So the first bit of shifting curves, translations, reflections. This becomes a lot more interesting. Shifting curves, part 2. Right, multiplying by a constant, what effect is this going to have? So if it's y equals a constant times function x, another way of thinking about that, again, I can separate that from the function. So it's the y value that's being affected here. It's really y divided by k is equal to function x. So it's the y values that are being changed. If k is greater than 1, then the curve will become steeper. Curve will become steeper. If it's in between 0 and 1, I'm not worrying about negatives. If it's between 0 and 1, the curve is going to be shallower. Another way of thinking about it is stretching vertically. Because it's grouped with the y's, it's like getting your graph and you're pulling it or pushing it down. So if it's greater than 1, it's going to be steeper. So am I pulling it up or pushing it down? Right. So I'd be pulling the curve up, making it steeper. If it's in between 0 and 1, I'll be pushing it down, making it a shallower graph. But that's if that constant can be grouped with the y. So y divided by the k. Right. The domain, so if we got overall the whole thing, the domain will be unchanged, but the range might change. I mean, obviously, if it was all real y, it's still going to be all real y. But if I had something that was, say, had a range between 0 and 2, and I'm pushing it down, the range is going to change. The domain will stay the same, but the range will change. Okay, here's the interesting thing. If we multiply the x by the k, k greater than 1 will still give me a steeper curve. In between 0 and 1, it'll still give me a shallower curve. Why? Because this time, if you look at it, when I've grouped it with the x and grouped it with the y, in the first one, it's actually y divided by the k. In the second one, it's x times the k. Okay? It's a horizontal. Okay? So k is greater than 1, the curve will be steeper. So I'm going to be pushing the curve in. Because if you push the curve in, it's all going to become steeper. The easiest way to imagine it is like a sine curve. Imagine you've got a sine curve. Push it in, it's going to get steeper. Pull it out, it's going to get shallower. It's going to be shallower. And this time, it might be the domain that changes. It might be the domain that changes. But the range, because when you're pulling it out, you're not doing anything to the range. It's going to stay the same. Okay, reciprocal graphs. So we want to turn the graph upside down. When we do that, x-intercepts will become asymptotes. Because you originally had 0, turning it upside down, 1 over 0 is undefined. So you're going to end up with an asymptote. Asymptotes, therefore, will become x-intercept. If the original graph y is greater than 1, when they turn upside down, y will become less than 1. And vice versa. Vice versa. So let's have a look at this. So on one graph, I'm going to draw y equals x. Ta-da! Y equals a half x. Now I can think of this as two ways. I can think of it as it's grouped with the x, but I'm multiplying by a half. Or I could think of it as y divided by a half is equal to x. But either way, the constant is a half, so I should be getting a shallower curve. So it's either means, if I'm thinking about it as vertical in this case, I'd be pushing it down. Or if I'm thinking of it as a horizontal, I'd be pulling it up. And so we'd end up with something like that. If I push it down or pull it out, we get something shallower. And 2x then would be the opposite. We get something steeper. But we can do that with any shape. So if I've got a parabola, there's my basic one. Whee! Y equals x squared. Same deal. This time, it's not times the x, because it's x squared. So the half is like, can't go in there, squared. So it's grouped with the y, if you like, this time. And it's a half is the constant, thus making it shallow. Right? Because we're getting it and we're pushing it down. We're not stretching, we're pushing down. And 2x squared, whoop. That one we're pulling it up. X squared plus y squared on 4 is equal to 1. So we're starting with the basic curve x squared plus y squared is equal to 1. This one's grouped with the y. I mean, it says y squared on 4, but I can think of it as y on 2 all squared. So the k, and it's grouped with the y, and when it was grouped with the y, remember we said it was y over k. So that k is 2, which is bigger than 1, so it should become steeper. Okay. So therefore, if it's a vertical push or stretch, and I'm going to become steeper, which one? Stretch. Okay. By a factor of 2. So that 1 moves up to 2, and we end up with an ellipse. There it is. Okay. Notice, domain did not change. Still in between -1 and 1. It's the range that changed. Okay. Let's do one of those reciprocal ones. So it's 1 on 2 minus x squared. You might know straight away what this looks like, but let's pretend we don't. The only thing I recognise there is x squared. Okay. What have I done to x squared? Oh, it's minus x squared. So I'll turn it upside down. Oh, hang on. I've got a shift. It's shifting up too. There. But now I'm turning this curve upside down. So the x-intercepts become asymptotes. There they are, minus root 2 and root 2. Anything bigger than 1 becomes smaller than 1, so that turning point at 2 will go to a half. Okay. So we'll turn 2 upside down, we get a half. Another key point to know is actually 1, of course, because turn 1 upside down, you get 1. Those points will stay the same on the curve. But the way I can think about it is imagine that's 1. Imagine y equals 1's there. Here, everything is above 1, so on my new curve it'll go below 1. Whereas over in these bits, yes, I'm dealing with negatives, but it's like I'm saying the curve's going the other way. Here, the curve is below there, so it goes above. And then I can do the same. Whoop, whoop, whoop. So what I'm saying is, if you think of 1, the original curve, if I start at the asymptote and go towards the y-axis, okay? At the start of the asymptote, until I hit where y is equal to 1 on the curve, that curve is below 1. So my new curve will be above 1 in that green area somewhere. Once I go past that, the curve is above 1, so it'll become below 1. So what I'll end up getting is that. Now, whether you shade the areas in or not, but all you really have to think about is, here's y equals 1. If it was below, it goes above. If it was above, it goes below. So it turns upside down. All right? So here would be -1. Below, it goes above. Above, it goes below. And it's got to bend towards those new asymptotes as well. So you get a feel for where it's going. So that red curve would be 1 on 2 minus x squared. X plus 1 on x. Okay, sometimes we like to construct these by simply adding the y values. So I've got a rough graph y equals x and y equals 1 on x. And I'm simply going to get a ruler and pick key points and add the y values together, or add the measurement together. You know, so the obvious points are things like points of intersection, because then you've got twice that y value. X-intercepts, well, there's none in this case. So going to add them together. Key points. X-intercepts, well, we don't have an x-intercept here because vertical asymptote there. 1 on x had a restriction in the domain. So when I add it with something else, that restriction is still there. It doesn't go away. So that vertical asymptote will still be there. So I'll draw that in green there. Points of intersection. Those values will now double. Because it's like I'll get my ruler and go, oh, okay, that's 5 centimetres. Both the 5 centimetres, add them together. I know I'll plot about 10 centimetres. And in this case, it would be negative. And if we're not sure what the graph's doing, I just pick different points and do that. So I might slide my ruler along here and say, oh, okay, this hyperbola is now about 1 centimetre. So I'll add 1 centimetre to the line. Now I'm adding about ½ centimetre to the line. And then as you're going along, it becomes pretty logical that, hang on a sec, what I'm adding is getting closer and closer to 0. So my new curve must keep getting closer and closer to the line y equals x. And so similar here. So we end up with something like that anyway. So we're just physically adding the y values together. I believe there's a really fancy word for that. I think it's called superpositioning curves. You impressed with that? Superpositioning. 2J.